Here we are with a question all about resistivity. Feel free to read the question and then press play when you're ready to see the solution. All right, it's always a really good idea to read these questions incredibly carefully because you're told a lot of information which you're then going to use to find ratios. And this is often used in resistivity, so the more practice with these, the better. We have uniform cross-sectional area, circular, and we have a new wire with the same length, same resistance. It's going to be important for later, half the diameter. We want to know the resistivity of the new over the resistivity of the old. So let's firstly get our equation for resistivity. Hopefully that's something you know, which is R equal to rho L over A. Now, if we rearrange that, it means rho is equal to RA over L, and that's going to be important because we're going to use this ratio to use the equation to find our ratio. Now, I'm going to sort of add subscripts here. I'm going to say that rho new over rho old, that's our density of new over the of the old. You could have just used N and O here, either would work, is now the R of new times the A of new over L of new, and the same for the old. That's a bit cumbersome, but I think it's really helpful to make sure that you're kind of keeping track of the variables here. Now, the nice thing about this is we're told in the question that resistance of the new and old wires are the same, that's the red, and the lengths are also the same, that's the green. And so therefore we can just cancel them and we're left with simply the ratios of the areas. And we don't need to worry about anything else. However, we do need to remember that this is a circular cross section, and so therefore we need to be thinking about d squared. Okay, well, pi d squared over 4. I'm sorry, I've missed a factor of 1 over 4 here, but that cancels anyway. Okay, we work through that. We've got the ratio of d squared, and then our ratio of d squared can be the ratio of d and then squared again. We know that the new wire has half the diameter of the old wire, and so therefore those ratios 1 over 2. Square that, we get a 1 over 4. Okay, now I've gone through that in some detail. One thing to bear in mind about this is if we get to that stage with the ratios of the areas, we know we're going from a large to a lower area. So really we can start ruling out some of the answers. C and D would provide a larger resistivity, and so therefore they are wrong. You can immediately rule them out. Okay, hope that's clear. Any questions, let me know.